Okay, so I want to do this up for 3B, 1B here because this might be my next page sets. Inside there, I'm looking for 5 of these, maybe 10 of them across the
Welcome
board.
back to Lockdown
But I
Math.
want to actually...
Today we are going to be talking about logarithms in kind of a back to the basics sort of lesson. The intent is for someone who maybe is not familiar with logarithms yet, or who has seen some of the rules but has been confused by
Especially
them.
with this Lockdown Math series. It's real good with my ASVAB setup here, so let's
because I have a couple
get
suspicions, but I think doing a live poll to see where everyone
what a
is
logarithm
might be helpful. So, if you can go to
there's a lot of different names for it, Jin,
which you can
Wizard,
find the link in the description,
whatever you want to call it.
and you can also just follow the link that's up on screen here.
Plushy.
You'll find a poll.
I know, I'm trying to hate myself.
At the moment, it asks, what best describes your relationship with logarithms?
Okay, we were on. There was a field trip with N students, and Y of them are
I've learned
males.
about them, but sometimes get confused by all of the properties.
They do sometimes.
I
So this is a
understand them,
clean
but
way
wouldn't know
to
how
get
teach
through
them. And D, I understand them
this
well and could comfortably
stuff
teach them to someone else to make them understand
real good,
well.
like real good.
So, we've got a good split. This is good and
Thinking like
interesting.
right in there in that area.
The intent for this
To
is
this
to create a
question,
lesson
why?
that I can
Why?
put
Because
people
this
to in the
question
future
important.
if they're
This
just not
question's
comfortable
super
with
important for
logarithms, and I wanted them
logarithms,
to say,
people.
oh,
I don't
here's a
know.
place that you can
Did I
go for
misspecify something inside?
how I think you could approach it intuitively. And for those who are in the camps of, let's say, understanding it but not knowing how to teach it, I think there's an interesting meta question around logarithms. Because I was scrolling around a couple teacher forums before doing this particular lecture. And when people ask, what is the hardest topic to teach in high school math, in the sense that students seem to have trouble with it the most, logarithms is one of the most commonly indicated answers.
3B, 1B big in here.
And I can guess maybe it's because
important,
there's a ton of these
again, in case
properties
this
that
is
you
our
end up having
first
to learn.
pass.
So if we skip ahead
About 3B,
where
1B?
we're gonna
Impossible
go. You've got all these
chess
piles of
problems?
rules, that just look like a bunch of algebra.
Yeah, they just look like a bunch of algebra.
Easy to kind of mix things up in your head. And I think when people have, these sort of nightmarish recollections of what high school math was like and what logarithms did for them, it's often those particular formulas coming to mind. What I want to do today is try to talk through, one, how to think about them, but also just on the meta level of if you're teaching somebody algebra, what are the points worth emphasizing? What's the way to get it?
Okay, now that we got that established, you're over here.
So let's go ahead and see how people are answering on this one. We've got a pretty even split between three possible categories. All right, so the most common viewer right now answered C.
This is fun for my logarithm series.
But they wouldn't know how to teach
the logic,
them.
the logarithm of an exponent.
Them well, and they could comfortably teach them. So this is sort of revealing that, okay, the existing audience...
Well, as an exponent, and if I had you on a 90-day boot barn, and you skipped all this in terms of your 90-day, you are an exponent. You are sine. You're the cost, everything around.
Now, if you watching are one of the people who
and you can tell because you logged it. You had it in the group with all the brothers and sisters in there.
So we're doing some live quizzing, and we're going to have an answer on here, and we're going to have people answering probably pretty quickly, probably correctly, given that, as you can see, most
so
of them
where was
are
it? There's actually one or two of them in here where I got it.
Don't let that be intimidating. Don't let that be something that indicates
kind of a
you should be
logarithm of an exponent. Yeah, here we go.
Getting the right answer.
You should be able to solve the logarithm with an exponent.
I think the most intuitive way to think about logs, if you're just going to start off,
by defining the logarithm,
at a very high level,
the exponent should find the sign.
Are something that can take in a power of 10, and it just spits out the number of zeros at the end of the number.
Well, that one I got moving on this direction, I think.
But just at the very high level, this is getting a sense for what they do. And I think it's pretty important. Because what you're saying here is, hey, look, as we walk from 1 to 10 to 100 to 1,000 to 10,000,
well, see,
each step we're multiplying
this
by
is
10.
a step. This is a wire. This is a battery. This is also the zero field of a battery, which makes this a wire by 9 volts. And no matter whether it's a wire, it's kind of got some charge to it. And well, that's the whole current in the current, the whole current in the. I don't remember.
It's the zero counting.
But at any rate, inside of the imps start banging around. They start jumping up. It's not ones and zeros. It's supposed to be though. You're right. Neutrinos get in the way of that. Our job, catch the fuzz. We gotta get it. It's been running around down here.
And these numbers
so here's what we do. We run this number. We do this one because we're not going to get much information off of it. We're not going to get a lot off of that there. But with Space Marine and and
in fact,
other ways to get him to go up and down this thing.
In the last couple of months,
interesting and useful.
What's kind of interesting is if you look at this Google Trends chart that's just looking for logarithmic
this can be
scale.
corn. And you know what? For all intents and purposes, it should be.
Scale, you'll notice, there's kind of an ambient
if you log corn, it was like, well, we're not really doing much inside here. We're, we sell cow farts and
for some reason,
keeping it up and then the harvest.
Strong interest in understanding logarithmic scales from the general public.
But we really ain't got nothing going in, but we're not really spending nothing. We had something come in, had something go out.
And of course, this is because this is when the corona outbreak was really starting to kick into high gear, and everyone wanted to understand exponential growth. And a common way that exponential growth is plotted
you were
is
here.
With what's known as a logarithmic
We helped
scale.
you get here.
So I actually made a video about
go
this,
through the roof,
and in it, I was, creating some
animations
that wanted to illustrate this idea of exponential growth.
Degauss yourself.
And the main idea here, I'll go ahead and skip back to a different animation, is if you're tracking the numbers, in this case, this was the number of recorded cases of COVID-19
I want to do the logarithm here.
China in the months leading up to March.
Okay, so
you could just track what the absolute
for
number
reals,
is, but the
that's kind of what she's going to do by different metrics of infinities.
Multiplicatively.
I got
it's a little bit like earlier we were seeing the powers of 10 one step to the next. You're multiplying by some amount. The way that the virus was growing was very similar. From one day to the next, you're multiplying not quite by a constant, but in this case, for this sequence of days,
and as far as the world is concerned, that's actually correct. But the momentum or the semi-imperial best twister theory here.
Classic exponential
you're
curve
logging.
That upward.
I know,
make it
right?
hard to see where it's going or what the overall
pattern it will.
So
while doing your stocks or numbers or graphing people or mapping the map out or doing whatever you got to do to do the hoodoo voodoo you do, you're going to start doing the twister theory. And again, that's going to help you tell the angle, she got to get rolling.
So you're going
we're
from
going to have some issues here in the mill.
1,000 to 10,000. All of these are increases by multiplying by 10. And what you could say is the y-axis is now plotting not the total number of cases, but the logarithm of the total number of cases. And this actually makes it kind of easier to see on a plot if you wanted to project out what that trend would do. And it's a little bit of a naive model to say, it's going to grow exactly exponentially. But in the early phases of something like this, that is what it is. So I kind of fast forward in the animation I made for that video. And what's interesting is if back then, I think I posted it on March 6th, if you just found a line of best fit and you stretched it out, and you said,
it starts at the yard dog, then you get to the forest rock crew, then you're the caterpillars. It doesn't matter, in this area, you're repairing a saw, you're hitting something with a hammer, and that's about as close to a 45 in the mechanics book, doing that transmission job somewhere else for the same pay during the day. Well, you still want to do that. Now, for some people, they might argue the log on that one there, but are they really keeping in line with the 45 of that 33 degree or 3rd degree burn they're about to receive?
And it's shocking that it matched so exactly. Thankfully, since then, the growth has stopped being exponential. So if you look at it on a logarithmic plot, instead of going up in a straight line,
you made this, huh? You're the guy that redid this, and you challenging his crown.
Anytime that you're coming across something in nature,
well, this was a little before that, but I'm assuming 3B been around for a while. One gorilla to another. Different.
So let's go ahead and think about what these actually are. How are they defined? Okay. And actually, there was a question asked on Twitter right before we started that I think hits this very perfectly. So Max182 asks us, additions, inverse,
this is some hot garbage equation. Now, if I asked you this logarithm, who knows how to use it? Who knows how to, what is it? You see, I equals 1. Alright, so I'm looking for I equals 1. You're going to say that is one of those things. Okay, sure, and n equals 0. And the number of that thing is 0. That's one of them, and the number 0? Yeah, that's the environment of a squared plus b squared.
I'll just draw it out for you, actually. This is going to be easiest.
Now, if you go about that just right in this alien spacecraft, bang, you've got one in hand. Now, if you've done it right, to the pie chart, right, Hadron Collider, you find the Higgs sitting in there.
And aside from writing it with an
that's me. Maybe that's not you. I bet 3B might.
We could also say